Hello, everyone. Thanks for your interest in our work. In this video, I am going to introduce our work, Phishing Web Page Detection with Semi-Supervised Deep Anomaly Detection. This presentation contains 4 parts. We first introduce the basic definition of phishing web page detection program, as well as the input and output of our model. Then we briefly discuss the existing phishing web page detection approaches and their weaknesses. Next, we present our proposed approach in details. Finally, we list the experimental results. Phishing is a kind of social engineering attack that tricks the victims to perform specific actions by imitating trusted web pages. It's currently one of the most prevalent attacks due to its effectiveness and low cost. The information used to detect phishing web pages includes the URL, the HTML codes, and other external information such as IP, DNS, etc. This gives an example of the HTML code of a phishing web page. In this work, we focused on using HTML codes as input and build a model that can predict whether a web page is phishing or not. Traditional detection methods typically focus on designing informative features and utilize sophisticated classifiers such as SVM or random forest. In recent years, several deep learning-based phishing detection methods achieved significant performance improvement. These methods typically use URL or HTML as input and utilize CNN or RNN to perform classification. However, these supervised deep learning-based methods require plenty of training samples to learn accurate decision boundaries. This limits the model's ability to detect unknown phishing web pages. On the contrary, anomaly detection approaches have stronger abilities to detect novel phishing web pages. But applying anomaly detection to phishing web page detection faces several challenges. Traditional anomaly detection methods require manually designed features, which is less effective compared to the deep learning-based method. Also, there exist several types of anomalies in web pages. Existing anomaly detection methods may detect other types of anomalies beyond phishing web pages. In this paper, we propose a novel semi-supervised deep anomaly detection-based phishing detection methods to address these problems. With HTML codes as inputs, we first employ a multi-head self-attention network to perform feature learning and output the anomaly scores. Then we use a prior distribution of anomaly scores to guide the model to learn a representation of normality. Finally, we utilize a novel contrastive loss function to fulfill end-to-end semi-supervised training to fine-tune the anomaly scoring network towards phishing web page detection. Consider a raw HTML code as input. We first split it into a sequence of tokens, bytespaces, and punctuations. Then we embed these tokens with an embedding layer that maps each token to a learnable vector. Next, we fed the above sequence of embedded vectors into an RNN to extract their local context features. The output of the above RNN is a sequence of vectors. Since the lengths of the HTML codes are variable, the lengths of the outputs are also variable. To obtain a fixed length vector representation for each HTML code, a common method is using the attention mechanism. However, vanilla attention only focuses on one type of information. This is insufficient for phishing detection, since it is crucial to synthesize multiple types of information from different locations of the HTML codes to accurately understand the anomalous behavior of the web page. Therefore, we adopted the multi-header self-attention mechanism on the output of the RNN. Finally, we utilize a fully connected layer and an activation function, outputting the anomaly score. To guide the training of the above anomaly scoring network to find good representations of normal HTML codes, a crucial task is to define appropriate learning targets. A naive solution is to use 0 as the learning target for all of the normal HTML codes. However, this may lead to the network to converge to a degenerate solution, where all the data points are transformed to a single point. To avoid this problem, we employ a Gaussian distribution as the prior distribution of the anomaly scores of the normal samples to generate pseudo labels. Using these pseudo labels as the learning targets of the anomaly scoring network provides a normalization effect and makes the model more robust to unclean training datasets. The output of the anomaly scoring network and the statistics of the reference set are fed into the contrastive loss to fulfill end-to-end learning. We first calculate the distance between the output of the anomaly scoring network and the center of the reference set. Minimizing this loss will push the anomaly scoring network to learn a meaningful representation of HTML codes and assign small scores for normal samples. In this way, we achieve end-to-end semi-supervised anomaly scoring training. Starting from the loss function, the gradient is first passed back to the attention layer, then to the RNN layer, finally to the embedding layer. To reliably evaluate the performance of the method, we collect a large set of real web pages. The phishing web pages are collected from PhishTank and OpenFish, which are widely used as data sources in previous phishing web page detection researches. For normal web pages, we build a crawler that treats Tranquil Top 1 million as the start point. Our crawler pays special attention to the login pages in normal web pages, since these pages are the common impersonate target. The competing methods can be grouped into two categories: supervised classification-based methods and anomaly detection-based methods. The performance of our proposed method and 5 competing methods are shown in the table. Our method outperforms other methods by a large margin in terms of a matrix except recall. Although isolation forest achieves better recall than our method, its precision is significantly lower. The better performance of our method comparing with the supervised classification-based methods demonstrates that our semi-supervised anomaly detection approach can utilize the labeled training data more effectively. Also notice that the unsupervised anomaly detection-based methods have significantly worse detection accuracy than supervised classification-based methods, but our method achieves better performance than supervised methods. Thanks for watching.